Hello everyone, I am Fitzroy and I'm excited to be sharing with you at the HCI 21 First International Workshop on Adaptive Cyber Defense. I am a researcher and adjunct professor at Florida Tech. I will be presenting our work entitled A Smart and Defensive Human-Machine Approach to Code Analysis. This work was produced under the direction of Dr. Marco Carvalho, who is the chair for the Health 3 Harris Institute for Assured Information here at Florida Tech. He's also the Executive VP and Provost. Static analysis is a well-known method for analyzing source code and fixing vulnerabilities. This work leverages static analysis using modern approaches to make it more useful in producing secure software and, by extension, secure networks and cyber infrastructure. We believe that creating systems that are helpful in adaptively defending critical resources should start at the ground level. Consequently, this work is centered around code analysis. First, I will present an introduction on the problem we're trying to solve. I will then discuss and demo an existing code analysis framework. Third, I will propose some enhancements to the existing system that will make it more adaptive in helping humans protect their networks. These enhancements include improving the existing virtual assistant that we have in the existing framework, adding a recommender system to make it more adaptable, and building behavioral models that will help us understand how humans behave as they use the system. Finally, we will conclude the work and suggest future work. Let me now present our introduction. Humans play a significant role in the safety and security of computers, computer networks, and other systems. Studies show that code-level vulnerabilities remain a top cause of data breaches across the globe. While this chart here is from 2017, it shows that security vulnerabilities contribute significantly to software failures, as reported by Tricentis. They were the ones who conducted this study entitled Software Fail Watch. In addition to this, in the 2021 Open Source Security Risk Analysis Report, OSSRA, which was published by Synopsys, it was reported that 84% of code bases that they scanned in a study contained at least one vulnerability. Nearly half of the open source vulnerabilities that were found in that report were identified as high risk. This accentuates the need for systems to work with humans to better secure their code and ultimately their computer systems. A terrible and costly result of unmitigated vulnerabilities is data breaches. Some people could care less about software security. However, most people care if their data is stolen, as this becomes a personal issue and could lead to identity theft and significant loss of resources, especially resources of monetary value. As you can see here, the average total cost of a data breach in the US for companies studied in this report in 2019 by Ponemon Institute, the cost has grown from 3.54 million in 2006 to 8.19 million in 2019, which is a 130% increase over 14 years. One way to stop this cascading effect is to start at the ground floor by eliminating vulnerabilities through constant static analysis and bug fixing. However, there are so many tools from which coders and security specialists can choose to scan their code. The big question is, which tool should I choose? As you can see from this chart, trying to select a tool from these lists of tools is overwhelming. For example, the Open Web Application Security Project, OWASP, lists 37 tools on their website. GitHub lists 285, and you can see the others here. This question leads to the purpose of this research. We are proposing enhancements to a code analysis framework which we have built. First, I will show you a coder working with our current system to scan code for vulnerabilities, and then I will discuss the proposed enhancements. Now let me present a quick demo of the system. The existing system allows users to work with their mobile device that has the Google Assistant app installed. The device could be the Google Nest or any other device that can run the Google Assistant. On the first image here is a screenshot of that is a tester would see when they're opting in to test the app. On this second screen is a demo.
Hey Fitz, the boss would like us to do a code review later. Are you ready?
Oh no, Atife, sorry, I have a few things to finish up and I would have to scan my code for vulnerabilities. Let's see if the assistant can help me. Talk to vulnerability scanner.
All right, let's get the test version of vulnerability scanner. Hi there, welcome back. This app is for finding vulnerabilities or clones in Java code. To begin, you can ask me something like, can you scan my code for me? Or, please check my code for clones.
Can you scan my code for me?
Okay, say IDE if you would like me to scan the code that you are currently working on in Eclipse. You may also choose a GitHub project from those opened in your browser. 1 for N, 2 for JetBrains, 3 for Jets AI, and 4 for Nuclear Glow. Or you can say, GitHub, if you would like to scan code in a public GitHub account.
IDE.
Sorry, what was that?
IDE.
Say, 1, if you would like me to scan the file, user tracker, or 2, if you would like to scan the entire WebGoat project that you are currently working on.
2.
Errors were found in the WebGoat project, 6 of high priority, 2 of medium high priority, 9 of medium priority. Say, give me more details if you would like me to summarize the errors found. You can also say, email me a report if you prefer that option. Or, you can say, no, thank you, to end the conversation.
Give me more details.
Overridable method, set value, called during object construction in the user session data method of the user session data class on line 16. Overridable method, create user, called during object construction in the WebGoat user method of the WebGoat user class on line 39. Do not hardcode the IP address in the null method of the integration test class on line 25. Do not hardcode the IP address in the null method of the integration test class on line 26. Do not hardcode the IP address in the isAlreadyRunning method of the integration test class on line 71.
Oh wow, let me fix those. Thank you.
Okay, see you later.
That concludes the demo. Now, let's highlight the extensions that we're proposing in our work. The current system that we have consists of a virtual assistant, a system integration framework, a code analyzer, and a report generation module. We would like to add a recommender system that will be enriched with data such as trends and reviews, tool descriptions, targeted projects, etc. This will help the user to select the best tool or code analyzer for their project. instead of having to search through the list of tools that we have discussed earlier. As you can see, this list is overwhelming. So that when we have a system that can recommend the tool, this would save the programmer a lot of time. In our framework, as you saw in the demo, the purpose of the virtual assistant is to work synchronously with the user to perform code analysis in a user-friendly environment. As a cloud-based agent, the virtual assistant can carry out tasks in a speedy and efficient manner as the user multitasks. Traditional code analysis frameworks may require the user to manually configure system preferences or specify certain parameters in order for the analysis tool to work effectively. This could reduce the programmer's productivity and discourage the use of static analysis altogether. Our goal is to automate many of these tasks, especially the manual ones currently, by allowing the agent to perform tasks on behalf of the user. For example, in our demo, the agent suggested that it could email a report to the user. We would like the agent to be able to make more helpful decisions, such as recommending fixes, or even making the fixes in place and documenting what was changed, perform a new scan, compare results, and provide insights to the user. The system integration framework that is mentioned here was discussed in prior work. However, we include a diagram on the next slide for reference. Currently, only one code analyzer is used in the system. We propose the inclusion of the recommender system to propose and use a scanner based on the metrics we have discussed earlier. When a recommender system is used, we can use the data involved to build behavioral models of how humans interact with the system. For example, we could capture data such as the times that a particular recommendation was given for a project. We could capture a value indicating whether or not the recommendation was adopted into the code base. We could even build a transition model that represents the steps followed by the user in the analysis process. This could help us detect things such as insider threats, where the user may intentionally reject a security recommendation and leave the system vulnerable to attacks. How do we propose to do this? We propose the use of topic models to understand the focus of a coding project. So given a coding project, as the user codes, we could build a topic model that will help us understand what the code is about. For example, it could be a security project, a banking app, and others. Once we know what the code is about, we now want to map a tool that is best for that kind of project. So we will use topic networks to capture topics about tools using short description and reviews. Topic networks are known to perform well on short descriptions. So for example, knowing that a tool is particularly suited for certain kinds of project, we can then say, okay, based on the type of project that you're working on, this is the most suitable tool that you should use to scan your code. Once that's done, this system now is adaptable to helping the user to fix their code and ultimately defend their network, because the recommender system is working adaptively based on the project to select a tool to scan the code. Instead of just picking a random tool, this tool will be the most suitable based on certain metrics. And in order to do that, we can come up with several features as we have discussed earlier. Here now is how the framework works with the assistant to get things done. So as we discussed earlier, the assistant device could be a mobile device, it could be a Google Nest or similar device that is connected to the network. We have several applications that are running in the background, such as a plugin in the IDE. We have a message queue in which the IDE can communicate with other applications to say, this is the project that the user is currently working on. As the user works, then we have the code analysis tool where the user can invoke the assistant device to say, go ahead and use this code analysis tool to scan the project that the user is working on their machine. This conversation goes on until the user is satisfied. Here now is our conclusion and future work. We have examined the challenges with finding and configuring existing code analyzers to adaptively defend computer networks and computer systems. We demoed a conversational code analysis tool that works with humans to scan code for vulnerabilities. We also proposed enhancement to the existing human-centered code scanning framework that will make it more resilient to mitigating vulnerabilities and adaptive against insider threats. Future work would include implementing the proposed enhancements and evaluating the system using A/B testing. Thank you for your time. For more information, you may contact me at fnembhard@fit.edu. Thank you.